I want to talk a little bit more about following the spirit of the a priori procedure in setting up or determining the sample size for this Big Five vignette study. Now recall that the primary goal here for using the a priori procedure is to plan our sample size so that we can give ourselves a reasonable chance of ruling out physical chance as a potential explanation for the pattern or any kind of pattern that we're going to see within the actual data. Now, when we're trying to rule out physical chance, we understand that's a kind of a low-hanging fruit. In the larger scheme of science, we really want to put ourselves in a position where we can have competing theoretical explanations for the patterns that we're seeing in our data, and then we choose among those competing explanations. That's inference to best explanation. Now, it can be handy to go ahead and rule out physical chance to kind of get that ball rolling, and so that's the idea here. Determining the sample size so that we can rule out physical chance to work our way ultimately to inference to best explanation. So with these Big Five data, or this Big Five study, suppose that I had planned my sample size at 142. So suppose I wanted to compute random observations. You can see I've been here before, 142, use these same distributions we've been using, and set up the data set. Now I've gone ahead and run the analysis and found the results for the randomization test, saved those, edited the distribution of PCCs, and we can see that we have 838 of the PCCs within that closeness range. But I want to draw your attention from this analysis to this upper unit here, this highest unit of observation. Notice that it ranges from 39.55 up to 47.18. So the maximum PCC from these randomly generated data was only 47.18, and that upper unit goes from that down to 39.55. So it doesn't seem that we need a real high PCC index then to rule out physical chance. Now with the actual data, we go to the data from the actual study. We did in fact collect 142 participants. So I ran the analysis on these data. I'll run it again just so we can see the results. So here you can see I've been here before. I've set up the pattern. I'm going to turn off the save randomization results here because I've already done this. Select OK. And notice that our PCC is 49.30. That exceeds anything that we got from those randomly generated data. So clearly we've got an odd result here, assuming physical chance. So we can rule that out with some confidence as a potential explanation for the pattern that we see in the data here. And then for the analysis of the actual data, we see the chance value is less than 0.001. Now let's also go ahead and take a look at the PCCs from the randomization test. And let's see how we did in terms of that closeness range. And here we found that 82.8% of the PCCs fell within that closest range, almost exactly what we had expected from the randomly generated data. So hopefully this gives you a better sense of how the a priori procedure works, why we're using it to plan sample size in the context of that chance value, which comes from the randomization test.